So you'll notice that I wrote on here, these are definitions. We're going to have, as I mentioned before, definitions and postulates and theories, and they'll come up in proofs. And when they come up, you'll say things like angle A is congruent to angle B, and then you have to give a reason. And the reasons could be a theorem, so you might say, I can't think of an angle theorem off the top of my head. Maybe they're in a triangle, so you might say side angle theorem, something like that. Or you'll say a definition. You'll say definition of vertical angles or definition of complementary, things like that. So you have to know the difference between them. Told you to make a page for formulas, make a page for theorems, and this would go on your definition page. So the vertical angles are two angles across from each other when two lines intersect. And form an X. What we know about vertical angles is that they're congruent. So whenever you have these vertical angles that are formed, excuse me, this angle is vertical to this angle, and they have the same measure. So if this is 80 degrees, this one will be 80 degrees. Okay. And then this angle and this angle are vertical, and they also have the same measure. So you get congruent angles across from each other when those lines intersect. So when we were looking at the worksheet and we had that X, those vertical angles that we identified in 1 and 2 would also be the same measure. So if you measured angle EKF, you would know the measure of angle HKG. You wouldn't have to measure them both. Okay. Complementary angles are two angles that add up to 90. Now these can be angles that are touching each other, adjacent angles. Again, like in our picture on the worksheet, those two angles that added up to 90 degrees, they can be sitting right next to each other and add up to 90. But they can be two angles floating off in space anywhere in the world. As long as they add up to 90, they're complementary. So a 30 and a 60, or a 45 and a 45, anything that'll add up to 90. You can have an 89 and a 1. And a way to remember complementary angles add up to 90 degrees is if someone compliments you, they're right. Okay, so that's just a good way to remember 90. 90 is a right angle. So if somebody compliments you, they're right. So complementary angles add up to 90. And then we have supplementary angles. And supplementary angles are two angles that add up to 180. Okay. And again, this can be any two angles. They can be adjacent angles that add up to 180, or they can be two angles floating off in space that add up to 180. If they are adjacent, they're not only supplementary, they're a linear pair. So these are adjacent supplementary angles. They make a straight line. And they add up to 180. Okay. So complementary angles, again, could be right next to each other, like this, and add up to 90, or they could be off in space and add up to 90. Supplementary angles can be right next to each other and make a straight line, so they add up to 180. Or they could be off in space and add up to 180. The linear pair, though, has to be touching. So to call something a linear pair, they have to be adjacent. They have to be connected and make a straight line. Otherwise, they're just supplementary. And these could be any measures as long as they add up to 180. So I'm going to say that one's probably about 35. So that would make this one 145. We have word problems. Yay. I know how much you love those. Find the measures of two supplementary angles. Okay, this tells me it's going to equal 180 degrees. If the difference in the measures of the two angles is 18. Okay, so I have two angles. So let's write down what we know. We have two angles. And angle 1 minus angle 2 would be 18 degrees. That's the difference. And then angle 1 plus angle 2 would be 180 degrees. Now we can set this up two ways. We can set it up as a system of equations, similar to what I have here, and solve a system of equations. If you guys want to, anybody remember solving systems of equations? Yeah, okay. Or we can set it up as one equation and just solve the single equation. Okay, so single equation, better? Yeah, okay. So what I have, if I call angle 1 x, okay, angle 1 is going to equal angle 2 minus 18. Because there's a difference of 18. So if I take one of the angles and I subtract 18 from it, it's going to equal the other angle. Sorry. Did I do that wrong? Nope, I did that wrong. I wrote it down wrong. Angle 2 is going to equal angle 1 minus 18. Because I already called angle 1 x. So that's going to be x minus 18. And it doesn't matter which one you call angle 1 and which one you call angle 2. I could have said angle 2 is x and angle 1 is x minus 18. I just need to know that one of them's x and the other one is 18 different. Does that make sense? Yes, no? Okay. Then I know that these two things are going to add up to 180. So x plus x minus 18 is going to equal 180 because they're supplementary. X plus x, that's two x's. I'm going to add 18 to both sides. And I'm going to get that 2x is equal to 198. And I'm going to divide by 2. And that is going to give me that x is equal to 99. That's the first angle. That's angle 1. Angle 2 is x minus 18. So that's 99 minus 18. So that is 81. Now to check your work on these, the angles are supplementary. That means they have to add up to 180. So to check it, I do 99 plus 81. long as it added up to 180, you have the two angles. Okay, we're looking for two complementary angles, so because they're complementary, they're going to equal 90. Okay, the measure of the larger is 12 more than twice the smaller. Okay, 12 more than twice is 12 plus 2 times. Because, twice is to multiply by 2. So we just have to say, okay, what letter do we want to use? Y? Okay. So 12 plus 2y is going to be the larger. And then the small one is just going to be y. So I'm going to add those two together. So the large plus the small is going to equal 90 degrees. The large is 12 plus 2y, and the small is y. 2y and y gives me 3y. I subtract 12 from both sides. Get 78. Divide by 3. And y is going to be 26. That's the small one. And then the large one is going to be 12 plus 2y. So that's 12 plus 2 times 26. So 12 plus 52, so 64 degrees. And then to check it, I'll do 64 plus 26. Now you might find the small angle and then say, well, I can just subtract that from 90 and I'll know the other angle. But if you do that, there's no way to check to make sure it was right. By plugging it back in and then you add it up to 90, then you know it was right. Because if you subtract from 90, then if you try to add it to make it, it's going to make it 90 no matter if you got this wrong or not. Does that make sense? So you never have to write the word ever again. The symbol for perpendicular is an upside down capital T or two perpendicular little lines. And then you never have to write out the word perpendicular ever again. If you were writing a sentence and you put this in the thing, I'll know you mean perpendicular. Okay? So it's any line, segment, or ray that intersects at 90 degrees. Okay? So if you have perpendicular line, this is when you have two lines. Okay. They intersect to form 4 right angles. So if I have 2 lines crossing, I get 4 right angles. Okay. They intersect and they form congruent adjacent angles. Okay, because these 2 angles here are adjacent, they're next to each other, and they're both 90. Now, if you have perpendicular lines, you have congruent adjacent angles. But if you have congruent adjacent angles, they're not necessarily perpendicular, because I could have 2 angles right next to each other that are 20 and 20, and that doesn't make it perpendicular. Does that make sense? So this kind of goes one direction, but not backwards. Okay. Segments and rays. Okay, so if you have segments and rays, you can be perpendicular to line. Lines or other segments and rays. Sorry, with this thing, my handwriting is just worse than normal. Okay, the right angle symbol, where we had, an angle with a little box in it, that's right angle, is also the symbol for perpendicular. Okay. And if you want to talk about, let's say, two perpendicular lines, if you want to write this line is perpendicular to that line, you'll write the lines. And put the symbol in between. So you would not have to write out like a whole, this is a sentence in math. This says line AB is perpendicular to line CD without having to write all those words. We want to find X and Y so that PR and SQ are perpendicular. So we're looking to make this line perpendicular to this line, SQ. Okay, which would make this a right angle and this a right angle. We don't know that it is yet because those marks weren't there. I just put them there. But we want to find out, okay, what does Y have to equal for this to be a right angle? And then we want to find out what does X have to equal for these to be a right angle. So I'm going to start with Y because that one's the easier one. Okay, so I want this angle here to be a right angle, which means it needs to equal 90. So I'm going to set 4y minus 2 equal to 90. Add 2 to both sides, and you get that 4y is equal to 92. And then you want to divide by 4. And that will give us that y is equal to 23. Oh, not degrees. Since y is not the whole angle, it's not a degree. It's just the thing that will make this 90 degrees. Questions on that one? Okay. On this next one, I want it to equal 90 also, but I have two angles in here, so I have to add those together to get them to equal 90. So I have 2x plus 5x plus 6. And I want that to equal 90. Does that make sense? Okay. Any questions at all on that? Okay. So 7x plus 6 is equal to 90. Subtract 6 from both sides. So 7x is equal to 84. Divide by 7, and you get that x has to be 12. Okay. So if I were to plug 12 into these, or 23 into this, that's how I could check this to make sure that it worked out. So if I plug in 12 here, I'm going to get 24. So this side would be 24 degrees. Take that out of the way. And then that's 60 plus 6, so this side would be 66 degrees, and if I add those together, I get 90. So that's how I can check myself. And here, when I plug in 23, I get 92 minus 2 is 90, so it works. The measure of angle D is 3x plus 12. Find x so that angle D is a right angle. So what do I need to do with this 3x plus 12? Okay, what do we know about right angles? 90 degrees. So I want 3x plus 12 to equal 90 degrees. Does that make sense? And then solve it from there. and you get that 3x is equal to 78. Didn't we already do this one? And x would be equal to 26. So as long as x is 26, that would be a right angle. And this, right now we're talking about perpendicular lines, but if we had any measure, like if they said the measure of angle D is 3x plus 12, find x so that D is 75 degrees or something, we could find it, we could find x for any angle measure. Just by them saying right angle, we know it has to be 90. But if they could easily say, find it so that angle D is 100 or 50 or anything. You would just rewrite it and set it equal to whatever that value is that they wanted. Oh, be sure at this picture. I can assume that all of these points are coplanar. Because they are drawn on like a flat surface. And that's what coplanar means, is all are on the same plane. I can say that G, H, and J are collinear. Because they're all on the same line. I can say that H is between G and J. However, I don't know anything about these two distances. Okay? Like I don't know that GH is the same as HJ or anything like that because it's not marked. Okay? I can say that L is inside angle MHK, but I don't know if it's a bisector or anything like that. I can't assume that without something to tell me that. I can say that these angles here, so I'm just going to call them 1, 2, 3, and 4, are adjacent. So 1 is adjacent to 2, 2 is adjacent to 3, 3 is adjacent to 4. Is it okay if I'm not writing this? I'm just telling you? Okay. I can say that. I can say that certain ones of these, like 1 and then 2, 3, and 4 all together is a linear pair. Or 1 and 2 and then 3 and 4 make, because they all make a straight line. You can break it up in that way, and you can say things that are linear pairs. And then you can say that they're supplementary because they're a linear pair. What I cannot say is I cannot assume any perpendicular lines because I don't have any right angles marked. I cannot assume any congruent angles. I cannot assume any congruent lengths because I haven't been told that. Okay? I can't assume any kind of midpoints or bisectors or anything like that. Okay, so for homework tonight, I would like you to do page 9, 11 through 13, and then page 10, 3 through 12.